Hi everyone, welcome. Today we're going to build Naughts and Crosses in Java, or more specifically 3 in a row. Okay, not the most exciting game, but a game with enough complexity that you have to take a structured approach to building it. It can be a little tricky in places, but also simple enough that we can get it all done in about 2 hours. So that's what we're going to do today. I'm going to be using Java. I'm going to be using Eclipse. I'm going to build this in a procedural way. I'm going to try, and I will not be using Java classes, at least as best I can in Java. So we're gonna kind of pretend this is a procedural programming language and only use static global variables, for instance, and methods. You should follow along with this. Pause the video, rewind if you get confused, rewatch pieces. I will try to remember to pause in places I'll give you guys some space to think about how you would solve some of the things that I'm going to be talking about. This video is unscripted, as you can probably tell. I'm not going to edit out my errors while coding. I think it's important that you see how I go about programming and constantly running things and kind of being just paranoid that what you're writing is correct and really thinking about things. So that's the aim, and I reckon about 2 hours, but we'll see how it goes. Okay, let's get going. I've got Eclipse open here in a fresh workspace. So the first thing I'm going to do is create a Java project. I'm going to call it Naughts and Crosses. That will do. Java 17 is fine. I do not want to create a module. So this is something I do not want ticked. I'm simply not building anything complicated enough to need one. Let's click finish. We've got Naughts and Crosses here. Let's go create a new class. I will call this class Naughts and Crosses as well. And I would like Eclipse to provide me a main method already stubbed out. Click finish to that. So here's my class, and let's make it do something. System.out.println. It's working. Let's see if that works. Click the play button. It's working. Good. Right, so we got a basic program up and running. With prints, the Java's working, the compilation is working, Eclipse is working, so we're good to start. Okay, to start, where do you start with building something like Naughts and Crosses? So if you're just sitting there thinking, you know, I know to write loops, I know to write variables, but putting all of this together, where do you begin? And this is a skill that's difficult to develop. Now, for me, I tend to really like programming in a bottom-up style, thinking about all the utility methods that I want to build, the small little methods that do very simple things, getting those working, putting those together to form more complicated methods that do a little bit more, and then building those together and going up until we approach the top level main method and finally putting that together. And that's kind of the way I build, with a bottom-up style, mostly. Sometimes I do a bit of top-down mixed in. But what I've realised, and only really recently it's dawned on me that I do this, I usually have a high-level plan or algorithm in my head about where this is going. That's how I realise what small methods I need. Now, I might not write this algorithm down on paper and really think about it too much, and it can change and be a bit fluid. But I do have that algorithm in my head, and I think I use that to guide myself on working out what methods I need. And so before we begin here, I think it's good to write this algorithm down so we work out what we're doing. So at this point, I think it's worth, let's write that algorithm down first. Let's get a basic algorithm on a sheet of paper without thinking too much about the complexities of this. So go and do that and join me back in 1 second and we will do this. Okay, so algorithm. What do we want to do? I'm just writing my thoughts down in plain English. Obviously Eclipse isn't really going to like this, but we'll make Eclipse live with it. We can use comments. So what do we want to do? Right, so let's print the board. So we need a way to print the board. What? Board? Good. We need to spell correctly. Right, so we print the board. After that, I guess we want to ask the user what row and column they want to put a piece in. Actually, if anyone doesn't know what we're doing here, Naughts and Crosses, you've got a grid of, say, 3, and first player goes, they put an X, second player goes, they put an O, first player goes, they put an X, second player goes, they put an O, first player goes, maybe they put an X here to block the O's, second player goes, they put an O here, first player goes, puts an X there and wins. So that's what we're going to be building. Okay, so I'll just run through a quick game there. So what happened? Right, print the board, then ask player for the row and column, place piece at row and column. Okay, that makes sense. That's kind of a turn, right? So that's a single turn. We will print the board, ask the player for the row and column, and place the piece at that row and column. Good. So that's kind of the idea of a single turn. Right, we're going to take multiple turns in this game. So while something is true, we want to be printing the board, asking the player for a row and column, and placing the piece at the row and column. Right. Good. Okay, that makes sense. While what? Well, while somebody has not won. So keep looping while somebody has not won. Okay. And after the loop, we exit this loop when somebody has not won. We can... What if the board is full? So you can draw in Naughts and Crosses. You can keep going until the board is completely full. And then, okay, so we need while somebody has not won and the board is not full. Right. So we can only exit this loop when either somebody has won or there is no more space on the board. So after this, we can do something like if somebody has won, print win message, otherwise print draw message. Okay, yeah, I kind of like that. So go down this loop while somebody has not won and the board is not full. We print the board, we ask the player for the row and column, we place the piece at that position. If somebody has won, we print a win message, otherwise we print a draw message. I'm avoiding things like validation and getting bogged down in the detail. I want a high-level plan. Maybe at the top we can have a welcome message. That makes sense. Anything else? Am I missing anything here? This doesn't have to be perfect. We can adapt this as we go. If I've missed pieces out, it's not a problem. But I think that gives me a bit of a starting point. So I'm going to keep this here and we're going to build this up slowly. Okay. Right, so where do we go now? Now I've got a high-level plan. What is the next step? Okay, so something that's clearly quite important here is the actual board, right? The grid of Naughts and Crosses. How are we going to represent that? So we want some sort of data type to represent this. It's a board. It's a two-dimensional board with rows and columns. The obvious thing that springs to my mind is a two-dimensional array. But of what type? We could do a two-dimensional array of strings, something like that in Java, where each cell contains the letter capital X, capital 0, or space. That would work. It's got the potential downfalls if I can type any letter and mess it up. Strings are a little bit slower to compare than integers. We're not going to see that because we're not comparing hundreds of millions of strings, but technically it's a tiny bit slower. I want to favour, though, I think, I'm going to use integers. Probably, if we were using classes, which I'm not going to use, I would probably jump straight to an enumerated type. Maybe I'll do another video on that later. But for now, I think I'll just stick with integers. So the idea here is this grid. Could represent maybe X is player 1 and O is player 2. So this would be represented as, and maybe we use 0 for empty. So the grid I just showed you there would be represented as 1s where player 1 would go, 2s where player 2 would go, and 0 where there is no piece at the moment. But terminology is important. I'm going to call this a board, and I'm going to call each coordinate of the board a cell, I think. Right. So we got a 2D array of integers called board, which is going to start off as a new int array of 3 by 3. Okay, so that means our indexes go from 0 to 2 inclusive. So how does this look? Okay, so to access in a single cell is something like board 0, 0, right? Or board 1, 2, board 2, 1. But what does this represent? One of these indexes needs to represent a row, and one needs to represent the column. Or you could think X and Y, or whatever you do, as long as you're consistent. I think I'm going to go for rows and columns. So I'm going to use X, Y coordinates, right? So X comma Y, that means X number of places across and Y number of places down. Or you could see column, row, right? So that, or col comma row. That's my idea here, okay? So then the first cell is going to be 0, 0. None across, none down. Then we're going to have 1 across, none down. Then we're going to have 2 across, none down. Then the next row is going to be none across, 1 down. I'm just drawing this out to get my thought process in the right place. 1 across, 1 down. Then 2 across, 1 down. Yeah. And the last one is going to be none across, 2 down. 1 across, 2 down. 2 across, 2 down. So those are my cell locations. Is that correct? This first row should all be row 0, which it is. The Y is 0. Then here we've got 1, 1, 1, and here we got 2, 2, 2, and then we got 0, 1, 2 as the column numbers. That's lovely. Okay, so that's fine. And so that's just, I'm just experimenting for a moment. Let's print a little board, or get a board set up. So let's have player 1, player 2, player 1. Let's have 3 zeros, and let's have 0, 0, player 2. Yeah, so let's just set that up, just so we understand what we're doing here, okay? So we got a board which is 3 by 3, indexes 0 to 2 on both axes. And I want to encode this in here, just to experiment. So we want here board 0, 0 is going to be player 1. When you instantiate an array like this, they start off as zeros. So they're all zeros, and I'm just going to change which ones I want to be 1s. So I want 1 across, none down. And that's going to be a 2. And then I want 2 across, none down is going to be a 1. I need semicolons. And then the last one is 2, 2, which is going to be a player 2. So let's just check that. 0, 0 is a 1, yeah. 1 across, none down is a 2, yeah. 2 across, none down is a 1, and 2 across, 2 down is a 2. You could design this in different ways. I've got the coordinate 0, 0 being in the top left. There's two major ways of doing this. 0, 0 can be in the top left, or it can be in the bottom left. But I'm picking top left. I'm doing that kind of because when you print in Java, you print down the screen, right? So if I print that row, it'll come out above me printing the next row. And that kind of makes sense to me at the moment. So we've got the board here, we've got this little picture. And looking at my algorithm, something that's clearly important is to print the board. Now, I don't know how far I'm going to get without being able to see what data is inside this board. So let me just try for a moment to do system.out.println board. I'm going to have to comment some of this stuff out because obviously it's not real code. I'm in my main method here, by the way. And let's see what it prints out. Absolute rubbish. So that's an identifier. Well, it's not an identifier. It's a representation of an object. I'm trying to stay away from objects. It's a representation of an object, an integer array in memory. Not useful to me in the slightest. Okay, so clearly to progress here, I want to be able to print a board. Yeah, that's the place I want to start. How would you go about this? Any ideas? Okay, let's go and build a method for dealing with this. So I'm going to go below my main method. I'm going to be abusing my main method all the way through this video. I'm not going to write the main method until the end. I'm going to use the main method to check other methods are working. So I want a method called, how about print board? Happy with that? It's going to be public and static. It's got to think about returning something in a moment. Open bracket, parentheses, and set up my squiggles. Apologies, I call these things squiggles as opposed to braces. Yeah, squiggly braces. Yeah. So what does this return? What type? You know, are we talking Boolean, integer, void, string, something else? Print in the board. I'm going to store my board as a global variable in a moment. Oh, in fact, why don't I do that now? Let's take my board, put it at the top of the class, call this static. Right. Now, I do not want many global variables, and I could do this without having global variables, but I feel like the board is going to be instrumental in many, many methods. I'm not going to have multiple games running simultaneously. This is supposed to be a simple example. So a single global variable to store the board, perfectly fine. So printing the board, it just needs access to the board. It's stored at the top as a global variable, fine. This isn't going to compute something. It's not going to produce a result. So the return type is going to be void. Now let's do this simple, and then let's build it up. I will warn you now, I'm going to make this method a little overcomplicated because I'd like a pretty board being printed, not something too plain. So let's have a look how we can do this. First of all, I'm going to call this method from the top. So instead of that line, I'm just going to replace it with a call to my print board. And let's see how it looks. So I'm going to come down and let's just do something plain for a moment. System.out.println board naught. So get the first cell of the board and shove it into the print method and print it. I should be printing the number 1. Yes. And if I move across to the next cell, I should be printing the number 2. So go 1 across, none down. Good. Well, that's working. Okay, it's not much, I agree. But I don't want to print numbers. That's not what I want to do. Now, I could be doing something like this, right? I could say, if the board at whatever cell, and I'll work that out in a moment, is double equal to 1, then, so if we play a 1, we print an X, else we print an O. Right? I could do something like that. It works, but that's complicating things. Let's have another method. Let's have a method that turns what is in the cell into the right symbol. So you can see me now going down. I now done a little bit of top-down development. I'm trying to build this method, but I've realized I need another method to make this work. So I'm going to put this on pause, and I'm going to think about a different method. So public static, it's going to return something. I need a name. I'm converting a value into a string. What type of that? I'm converting a board value into a cell value. Cell value to string. No, to what is the string? String is too generic. Symbol. Cell value to symbol. Okay, right. What do I need to take here? I need to take the particular cell value you want to convert, which is an integer. And what do I want to return? I want to return the symbol, which is going to be a string. I can write some Javadoc as I go here. Let's do that. Convert a cell value to a printable string symbol. Okay. Apologies for my spelling. The cell value to convert, which is going to be 0 to 2, and return the symbol representing the cell value. Okay, good. Return 42 for a moment. I put 42 in place. I can't return 42. I'm just going to return the string 42 for a moment. This tends to be how I program. I always want to have compiling code. I'm going to put this at the top just to call it. And this is exactly what I mean by destroying my main method to see if these methods are working. So I'm going to call this. I'm going to pass in the number 1. That's going to convert the cell value 1 into a symbol to print, and I just want to send that to the printer. Oh, what have I done here? Right, that's what I want. Take the number 1, turn it from a cell value into a symbol and print it, and that should give me an X, right? Once I've finished building this. At the moment it's going to give me 42, which is obviously not right. Okay, this is simple. I can use some ifs. If it's 0, it's a space. If it's 1, it's an X. If it's 2, it's a 0. But I think I'll use a switch statement instead. Switches are a little bit cleaner. Okay, Eclipse can write this for me. Yeah, I'm happy with Eclipse doing some programming. Yeah. Okay, so we switch over the cell value. If the cell value is a 0, I'm not going to use yields, just use simple returns. We're going to return a space, which is different to the empty string. I don't need that there, do I? Right, it's a series of these, right? Right, if it's a 1, I want to return an X. If it's a 2, I want to return a O. I think I've done that right. Right, what's this? Okay, default on a case. You should program defensively. I want the program to tell me useful things when things go wrong. When I make a mistake, I would like to know about it. So in this case, if I'm only ever expecting me to call this method with values 0, 1, and 2. But let's say I mess up. What if I mess up? Then, okay, default. We'll throw a new illegal argument exception. We'll abort. And yeah, a little message, unexpected value, cell value. Illegal argument exception sounds correct. The argument coming into this method is illegal. It's not valid. It's only legal between 0 and 2. That's perfectly fine. Now, I never expect to deal with this exception in my program. It should never happen. This is not a normal exception. This is a programming error. If anyone calls this method, including me, with a value not between 0 and 2, they have made a fundamental mistake. I don't need to catch this error, this exception. I don't need to deal with it. If this occurs, there is a programming mistake. So I can fix the error. I can fix the programming mistake. Okay, let's see if this goes and works. So this now converts a cell value into a symbol, into a string. Let's see if it works. Let's convert number 1 into a cell value, into a symbol and print it. We get an X. Let's put number 2. And we get a O. And let's print a blank cell, number 3. And, yep, this is exactly what I mean. So a blank cell is not number 3, a blank cell isn't 0. And so by passing 3 in, I get an exception, nice and red, tells me exactly what the problem is, tells me the line number. It's this line that's the problem, line number 6. I didn't mean to type 3, I meant to type 0. Click play. Okay, there's a space being printed there. Kind of hard to see, but that works. So let's go back to our other method. So I'll comment my board back in along with the print board method, and we will go back to our print board. Let's do a little bit of Java doc. Print the game board. Right, so now instead of doing this type of thing, I can literally do system.out.print line board naught. Okay, let's try that. We should get cross printed. Oh, yeah, okay, we get a 1 printed. I want to wrap that board in my new method. So take the value at a particular cell, turn it into a symbol, print that symbol. Okay, we got a cross. Now we could do this in a very obvious, verbose way. Naught across, 1 across, 2 across. Okay, let's try that. Oh, okay, I don't want the first 2 to put a new line. So we do that. I could then duplicate this code. So this one is going to be column 1. Row 1, sorry. This is going to be row 2. 2 across, 2 down, right. Okay, and we've got this picture, right? 1, 2, 1, 2. X, O, X, O. Yeah, that works. Doesn't look very pretty, right? And we can see I'm repeating code here all over the place. So let's have a bit of a think. What's happening here? Each of these is printing a row, right? So to print a row, what am I actually doing? I'm looping 0 to 1 over the first component. Right. So for int col is 0 while the column is less than 3, not to 2, column plus plus. And all I want to do is print out naught. I'm going to do naught, print out column naught for a moment and see how that works. I'll just comment these out. This is probably one of the most complicated methods to write, okay? So bear with me here. We've got to get the board printed first. Right, so we got the top row, and then I can run over this with multiple rows, right? So I can do a similar thing here with rows. Row, row, row. Oh, no. Where am I putting my brackets? Am I putting my squiggles up or down? I think I'll put them up. Is that what I've done elsewhere? Yeah, I'll put them up in the normal Java style. Okay, let's try that. Oh, here it is. What have I done? Roll. Roll. Go. Okay, I need some new lines. Print a row, and after I print a row, I want system.out.print line. I just want to print line. Let's try that. Okay, that looks nice. That's not good enough for me though. Right, so I've kind of got the board printed. I'd like some separators. So let's work on some walls here. So before I print the cell value, no, after I print the cell value, I'm going to print a vertical bar. as a wall. Let's see how that looks. I don't want a print line, I just want to print. I don't want a new line after it. Okay, that's looking better. Maybe some spaces. A space there. Okay, let's put a space before it as well. Right, I'm kind of used to this geometry code I'm doing here. Somehow I end up tending to do a lot of this type of stuff, and I'm fairly reasonable at knowing where I want to put stuff. I'm also trying to go slow here to explain what I'm doing. So I got a space, the symbol, space line, that gives me that. I need to put a line in front. So before I print a row, before I start looping over the row, I need to print a blank line, and then the space comes from there. So I'll be happy with that. So let's try that. That's looking good. Now I'd like some lines going through. So after I finish this print, I'll do something like, so after I finish doing the row, I'll print another line with 1, 2, 3, 4. 1, 2, 3, 4, 1, 2, 3, 4, plus 1. So each cell takes up 4 characters. 1, 2, 3, 4. Space, symbol, space, wall. Space, symbol, space, wall, plus the original wall at the front. So 4, 8, 12, 13 characters. Okay, so that works. And then I want that right at the beginning as well. Starting to look better. I don't really want to repeat code. Let's make that a sort of a mini constant. String separator equals this thing. And here I can put sep, and down here I can put sep. Let's see how that goes. Looks the same. Good. Maybe I'll make my separator a little bit more funky. Okay, I can live with that. Let's stick the numbers on top as well. Right. 0, 1, 2. No one, right. So I need to put these in the right place. It's not going to be right. Another. Okay, cool. Now, this is row Z. This is column 0, row 1, and row 2. Oh, what am I talking about? See? Column 0, column 1, and column 2. Yes, those are the indexes. But humans don't count from zeros. Humans count from 1. So, let's pretend with input-output that we're dealing with real human beings. So, 1, 2, and 3 as numbers. Okay, now I need numbers on the side. So I get before I print the wall, I need to print the column, right? So print the column and then add on, sorry, print the row number and add on the first wall. Not bad. I need a space in front of the wall. Cool. I need some spaces in front of my sep. I think it's 1, 2 spaces. Not bad. I need some space in front of my numbers. Not bad. I shouldn't be counting from 0. I should be counting from 1. So where's that gone? That's here. So it's row plus 1. Good. That's nice. That looks good. Am I happy with that? I am happy, except I've got magic numbers everywhere here. 1, 2, 3. 3, 3. What if I want to play a board of 5x5 or 6x6? You got a choice here. You can skip over this part, or you can follow me down a little short rabbit's warren of generalizing this so we can have an arbitrary size board. I'd like to do that now to give you a bit of an idea. It's not mandatory. If you just want to always build Naughts and Crosses for 3x3, this print method is perfectly fine. But if we want to generalize it so we can have arbitrary size grids, it's not too bad. So let's do that. Let's go up to the top and make a constant. Static final int board size. And it's going to be 3. Okay. And down here, instead of instantiating to 3x3, I'm going to instantiate it to the board size. I'm going to assume I've always got a square board. I don't want rectangular boards because it makes checking diagonals a little more tricky. I got to think out what that would mean. So I avoid that for now. Right, so let's see if we can just generalize this a little bit. So if I put board size in for the loops and click play, let's see what happens. Oh, it looks the same. Of course it will. Let's change this to a 5x5 board. Okay, so this part's working. Yeah, I'll put another symbol in the position 4, 4, which is the very last cell because our indexes go from 0 to 4. Good, so we got no in the bottom position. What's not working here? These separators are not working, right? So my separator now needs to be the dynamic length. The length of it is based on the number of cells. So what have we got? We've got a first wall plus some space. So let me split that out for a moment. So we've got the initial part, which is always going to be consistent. That part's always consistent. And then we print minus, 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 plus for however many cells we have. So I could use a loop to do that. Or I'm going to use a new feature in Java 10, I think it was, where you can ask a string to repeat itself. Yeah, well done, Eclipse. Yeah, I want to repeat board size. I think that will do it. Okay, so if anyone, let's take a step back for a second, just in case anyone's confused about that. So system.out.print line. So if I print the string apple, then we're going to get apple printed, right? But if I do apple.repeat 6, then we'll get 6 apples printed. That's all repeat does. A string.repeat produces the same string repeated that many times, and then I printed it here. Okay, so let's get rid of that. Let's put our board back in and go to the bottom. Right. So what we've got here is this thing, minus, 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 plus, repeated however many times for the size of the board. So in this case, 5 times. And we stick a space, space, plus on the front. And we end up with that. Okay, our rows are coming down there. The last thing is these numbers. I can't think of a good way of doing that right now. So I think I will just loop over it. It's got to be a loop, I think. Might be a better way of doing it, but this will do. System.out.print line, not print, col +1. Let's get rid of these. Let's get rid of that. Print col numbers. Yeah. Just little comments to let me know what I'm doing. Let's try that. 1, 2, 3, 4, 5, not bad. I need a new line after the end of it. So that will push it down, and I need some spaces around it. Do you know what? I'm going to do slightly differently. I'm going to put it in here. So I'm going to have a space plus print in the col +1 plus a space. Let's see how that looks. That is good. I think that's correct. Is it? And I just need to nudge it over a little bit at the beginning. So I could do a system.out.print line space space. Let's try that. Oh, not a print line, sorry. Print. Perfect. So now I can have different size boards. So I can have a board of 7x7. Way. Or I can have a board of 3x3. I'll go back to 3x3. Exception, index 4 to bounds, line 14. Oh, here, yeah. Okay, I've gone back to a 3x3 board, so I can't put something in position 4, 4. Nice. This isn't going to work if I make the board be, let's say, 13 by 13. Why? It looks fine. But it started to go wrong here, look. 10 takes up 2 cells now, and 11 takes up... It's all going off, and down here is going off. I'm going to ignore that. I could fix that too, but let's just assume the boards have played between what, 1 and 9? Can we have set 1? Oh, yeah, I got the same problem. Let's comment those out for a second. Does this work with printing a board of 1 by 1? No, it does. There we are. That's nice. Okay. And 2 by 2? Oh, super. Okay, right. Anyway, let's go back to playing by 3 by 3 boards. And I think we've spent enough time on a print method. We can now print the board. Okay, I've gone a bit overboard there, I guess. But my board looks nice, and it can be customized to different sizes. So I can now forget about this method. I've got the ability to print a board. Maybe we just check if it is always working. I think it is. If I go and put an X down here, so that would be player 1 in position 0 across 2 down. Then we should get an X down here. Perfect. So now I've got a board representation. A 2D integer array, 0 represents blank, 1 represents player 1, 2 represents player 2, but the 1 and 2 are printed with the correct symbols thanks to my cell value to symbol method, which I utilize in the print board method. So I think we're well on our way here. Good. Okay, where do we go next? Now you're probably thinking I've spent 40 minutes and all I've got to show for it is a print board method. Looks pretty, but that's 40 minutes. That was a bit of a long one. The rest will go a bit quicker. Right, so let's tidy up here. I think we know what we're doing with this. Let's go back to our algorithm. So let's look at our algorithm. Print a welcome message, easy. Now we can print the board. Those look okay. I think this body conditions look complicated. While somebody, spelled badly, while somebody has not 1 and the board is not full. Let's tackle those. Board is not full. Okay. That sounds like a easy thing to implement. Board is not full. I could reword that. And not board is full. Yeah, let's go with that. Board is full. That sounds like an easy method to implement. Okay, let's go down. Public static something. Board is full. Is board full? Board is full. Check board is full. I'm trying to think of the method name. I think I will go with is board full because it, yeah, is the board full? Is board full? It's going to return a boolean, right? The board is either full or not full. Okay. It's complaining because I'm not returning something. Return false. Is board full? So we got our board made up of numbers 0 to 2. The board is full if all the cells are not 0. So let's loop over the entire board, and the minute we find a cell that's not 0, we know there's a space. Yeah, that works. And so we can loop over all the board. If we find a cell that's 0, we know there's a space, and if we get to the end of the loops, we know there's no spaces, so the board is full. Yeah, okay, let's do that. So for int row equals 0, row is less than our board width, board size, row plus plus, loop. And we can do the same again, except this time it's for columns. And in here we can say if board col row, let me just check that, board col row, is that what we were doing here? this many spaces across, this many spaces down. I'm going to put that up here as a comment before I forget. Col, comma, row, or x, comma, y. That's always how we represent the board. Yeah? Coordinates are... Right, that'll do. What am I writing? Coordinates. Okay, I give up spelling. Fine. Is board full? We got the row size. Right, so if the board at this particular column and row is equal to 0, then we know we found an empty space. So we can return false. This method is going to return false when the board is not full. Okay. And if we get to the entire end of the loop, we will return true. The board is completely full. Okay, let's do a little bit of JavaDoc. Check if the board is full. Return true if the board is full. False if there is at least one space. There we go. Happy with that. Let's check it works. Let's go back up. I'm going to comment. Oh no, we can print the board method. Then I'm going to do system.out.print line, and I'm going to call my isBoardFull method, which should print false. Good. Let's fill up the board. This will take me a tiny bit of time. Row number 2. Do you know what? Let's just copy row number 1 and put it into row number 2, which is index 1. Still false, we still got one space. Let's fill up that space. I don't care what's in there, I'm just filling it. Good, true. The board is now full. So I'm fairly convinced that works. Now, what I should be doing here, I'm not going to, but printing this out and destroying my main method all the time, I could just move to unit tests. I could put that as a unit test and check true and false depending on the setup. That would be a much more robust setup where I can reuse my unit tests if I ever change the code and as I go along to know I'm not breaking something. But for now, just putting these in the main method like this is fine. So if I take any one of these out, then that should go to false. Good, I'm convinced that's working. Okay, so now we've got our utility for this part, and why, well, we could even change this, and not is board full, right? I'm almost writing the code now, look, there we are. Right, cool, because we got a method, and not in Java is an exclamation mark, while not board is full. Cool. Somebody has 1, somebody has not 1. Okay, time for another method. Checking who has 1. How do we do this? This is probably the most complicated part of the game. Okay, so I'm going to have a method, public static, not sure what it's going to return at the moment. Check who 1. Check who 1. What's this going to return? Let's do the JavaDoc. Let's see if that helps me. So it's going to see who's won the game. What are the outcomes? Player 1 can win. Player 2 can win. It could be a draw. Or it could be ongoing. So this isn't really checking who won, because it could be a draw. Check who won says who won. It's not the right sentence. What we're really doing is checking who's won, but it also could be a draw, it could be ongoing. What are we doing? We're checking the game state. Yeah. We are calculating the game state. That is what we're doing. Calculate the game state, board state. How about board state? That's better. Calculating the board state at return. Right, so we could say, what are we going to return? So I want this to calculate the board state. What data does it need to do its job? It doesn't need any because it can just use the global board. How about we return 1 for player 1 wins, 1 for player 1 has won. 2 for player 2 has won. 0 for a draw. And how about -1 for game is ongoing? How does that sound? I'll just put some blank lines in here just to line it up a bit better. I think that sounds okay. -1 for the game is ongoing. 0 for a draw. 1 for player 1 has won. 2 for player 2 has won. I can get on board with that. That sounds reasonable. I've got to spell things correctly. Oh, I'm going to have numbers all over the place here. -1, 0, 1, 2. I'm going to have numbers everywhere. Normally I'd reach for an enumerated type, but I'm trying to avoid them. But I think I will give these things aliases. So what I'm going to do here, I'm going to say, I'm going to have 4 aliases. Board, state, ongoing. I don't like board state. I've changed my mind. I want to change it to game state. Game state ongoing. Check the games. Calculate the game state. Calculate the game state. Yeah. Game state ongoing is going to be -1. Game state draw is going to be a 0. Ignore the formatting for a moment. Game state player 1 wins is going to be a 1. I can live with that. And we're going to have a 2 for player 2 wins. Right. So those are my aliases. Yeah, they're longer, but Eclipse can write this for me. It tabs completes. Yeah, let's make these things real. I'll put these as sort of global variables at the top. Again, if you know what an enumerated type is, I would use those. So constants go at the top. Game state values. Static final int. Oh my gosh. Eclipse, what are you doing? Okay, not too bad. Right. That's kind of what I want, right? I'm going to copy those down here for a moment. I don't want them here, I just want to be able to copy and paste. So we're going to return that. Ongoing. Is ongoing 2 words? I think ongoing is 2 words. Not sure. We'll find out. Is ongoing 2 words? Google. Ongoing is 1 word. Right. You see why programming takes me a while. I worry about the names of words. Okay. Ongoing. Right. A draw can be here. Player 1 wins can be here. And player 2 wins can be here. Yeah. Maybe I'm overdoing it with the Java doc, but I prefer to know exactly where I am and not make mistakes. Right. This method is going to calculate the game state. It's going to return this value for the game is ongoing, this value for the game is a draw, this value for player 1 wins, and this value for player 2 is wins. Yeah, I like that. Okay, it's going to return an integer. Oh. Okay, cool, right. So, let's just return game state ongoing for a moment to give myself some space to breathe. I'm just going to set this up at the top. So I'm going to do a system.out.println, and I'm going to call that method, and it should print the right thing. Okay, at the moment it's just going to print -1, which is our ongoing. Okay. How do we go about building this? Well, okay, let's flesh it out with some algorithm idea. And I'm just, again, typing high-level code. This is supposed to check or calculate the game state, right? So first of all, we need to check for wins in rows. Yeah? We can do that. Okay, then I guess we can check for wins in columns. Then I guess we can check for wins in diagonals. Okay, those sound like methods to me. So check all the rows. If we find one of the rows is a win, we're done. Check all the columns. If we find one of the columns is a win, we're done. Check the diagonals. If we find all the diagonals are done, we win. If we didn't find any wins, then the game is a draw or ongoing, depending on if there's space. Okay, that sounds like an algorithm. Hang on. Check for wins in rows. If any, stop as there is a win. Okay, that would apply to each of those. Yeah. Otherwise, we get to the end and we can say now we found no wins, so it's a draw or ongoing. That makes sense. Do you know what? I think we can write that part of the code, but I'm not going to at the moment. I'll just say if board is full, it's a draw, else it's ongoing. Right, there's a little algorithm. Now to do this, we need to check for wins in rows, columns, and diagonals. So those sound like new methods to me. So I'm again going to put this on hold and go and build some of these methods. So let me copy this bit of block of code because I think it's going to be similar. Calc game state. I'm trying to think. I'm sorry. Let's think out loud so you guys can follow along. I want to check a particular row. Right, so I want to check a particular row. The row I want to check, I'm going to pass in as an integer. Okay, so please check this row. And check in this row for a win. How about that as a name? Check row for win. How about is row win? No, that implies a boolean. Check row win. Yeah, check row win. Let's go with that. Check to see if there is a win in a particular row. Okay. At param row, the row to check 0 to board size -1, right? Okay, and what are we going to return here? I kind of like returning the state. 1 for player 1 wins, 2 for player 2 wins. This method cannot possibly check there's a draw. This method only looks at one row and tells us if that row is a win. It cannot tell us if there is a draw. So it's not going to return that for sure. Oh, my spacing's out. Oh well, no. What was? Oh, sorry. There we are. Right. So, one, if player 1 has 1 in this row. Yes, I like that. 2, player 2 wins if player 2 has 1 in the row. Ongoing, yeah, if nobody has 1 in this row. How does that sound? I feel like I'm abusing this constant. This is supposed to represent the game state, not a row state. But do I really want to create 3 more things? Row state, player 1 has 1, player 2 has 1, row state ongoing. They're basically the same thing. I think I'm happy using those. So check row for a win. So checking a row, they can all be crosses, in which case player 1 has 1. They can all be zeros, or O's, meaning player 2 has 1. They could be a mixture, meaning nobody has 1, or it can be ongoing. What if it's full? If it's full, I'm saying it's ongoing. It's not really ongoing. It's there are no more spaces though, right? There's no more spaces, but nobody has 1. I think I'm happy with that. It means the game is still ongoing, possibly, right? Yeah, I think I'm happy with that. Okay, so how do we go and do this? So specifically, we're returning -1 if it's still in play, as in we can't tell anyone's 1. 1 if player 1 has 1, 2 if player 2 has 1, right? So how do we do this? But you know what? Let's just keep this simple. Let's keep this really simple. Let's do it verbatim first. Verbatim, verbosely, and see. Right, so we've got to check all 3, I'm assuming 3 for a moment, 3 columns in this row are the same. So, if the board at column 0, row this is equal to player 1, and one, 2. Right. So 0 across rows down is player 1. 1 across rows down is player 1. 2 across rows down is player 1. If that's true, then player 1 has 1. Okay. Else, if... Oh my. Do you know what? I don't really need the else here because you can't get to it because I would have returned early. So, yeah. So if these are all equal to 2, then we can return game state player 2 wins. And otherwise we can return game state ongoing. Right, let's go see if that works for a moment. Okay. So again, I want to abort doing the calculate game state and think about this. So I'm gonna replace that with check row for win, and I want to check row number 0. So looking at my board, it should be a -1. Wait, it's a -1. Let's make player 1 win. So if I change that to a 1, I should get a row of 3 X's across the top. I do, and we get a win. If I change this to row number 1, which is the middle row, I should get a -1 again. Good. If I change the last row to all 2s, and change me checking to the last row, then we should get a number 2 to indicate player 2 has 1. That seems to work. Change this to a 1, meaning it should ongoing. -1, good. The last row now, I'm checking the last row, number 2. Row number 2. Row number 2 here is not winning -1. Yeah, check row for win seems to work. However, I haven't done this isn't going to work if I change my constant, right? So if I change my constant up, then I'm only checking these 3 by 3 now. I'm not checking everything. So I should really fix that. So this needs to be a loop. See, if I didn't make my board a generic size, I wouldn't have to do this. If I fixed it to 3 by 3, I'd be done. The minute you start generalizing things, you make the code harder. Shouldn't be too hard though. Let's have a look here. I want them all to be the same, right? So I certainly need a loop. So for col equals naught, col is less than the board size, col plus plus. I certainly want a loop. And I need to check they're all number 1, right? So how about I have here a Boolean player 1 wins. I'm going to set it to true, and I'm going to use a sort of observation that we prove player 1 doesn't win. So let's assume player 1 wins. I loop through all the columns, and if the board at the particular column with the row that's passed in is not equal to 1, then we've proven player 1 does not win. Player 1 wins is false. Does that make sense? Assume player 1 is 1, loop over all the columns, check each column at this particular row, check if it's not -1. If it is not -1, i.e. player 2 is there or it's empty, then player 1 definitely is not 1 in this row. If we get through this entire loop and player 1 wins is still true, then player 1 is 1. So if player 1 wins, that's a Boolean, right? I can do that. Lots of people seem confused by this and would write if player 1 wins is equal to true. I don't need to do that. Player 1 wins is already a Boolean. If player 1 wins, then I can just return it. Then I can return my constant. Yeah, I like this. That's fine. So here we say check if player 1 wins. I'm happy with that. I think that'll work. And yeah, I could probably make another method out of this too, but I think I'm going too far if I do that. So I'll just duplicate it. I'll check for player 2 wins. I'll make another variable. Player 2 wins is false. If player 2 wins, game state player 2 wins. Okay, so we check player 1 wins by looping over the board, looking at all the columns and seeing if they're not -1. If they're not -1, we've found somewhere where the player doesn't have a continuous line of pieces in a row, and so we set it to false. Only if it's true do we abort early. We then check player 2. If we do all of this, then the game must be still ongoing. That looks right to me. Am I confident it's right? No. So let's play a 5 by 5 board for a moment, and I'm going to check row 0. So nobody has 1. I got 2 squares to fill. So let's do a 3 and a 4. I got all 1s, so player 1 should have won. Yeah, cool. Let's try to change it to 2s. Cool. No, not cool. Not cool at all, Liam. What is going on here? I got all 0s, all player 2 in the first row. I'm checking the first row. I get a -1. Something is wrong. I found a bug. What is wrong? I went through this very quickly, changing all the player 1s to player 2s. I forgot to actually change the comparison to a 2. Run it again. And now we get player 2 wins. Good, that looks like it's working. So now, yeah, cool. Right, let's change the board back to 3 by 3s because it prints a little smaller as well, which is easier for my screen capture. Okay, I'm just going to make it so player 2 has not won. Good. Okay, so now we've got the ability to check the row for a win. Very nice. I think now we can use the same principle to make another one, where we can check a column for a win. So we pass in a particular column, check to see if there's a win in a particular column, col the col to check if nobody has won in this column. Col, yeah, let's use human words, Liam. Right. Check if player 1 wins, player 1, right. So now I need to loop over the rows. And if the board at this column and row is not -1, player 1 wins is false. Yeah. I now need to loop over the rows. And if the board at this particular column and row, this many across, this many down, is not 2, same logic. Perfect. Job done. I think that works. Column for win. Yeah, let's go check it. So instead of doing row for win, let's check column for win. So we're checking column 0. Let's see how that looks. Column 0 is the first one. No x, o, -1. Yeah, no good. If we change the 1 to a 2, we should have player 2 winning. Change the wrong cell. None across, 1 down, this one. Yeah, we get player 2 wins, all O's. If I change these to a 1, that one, that one, that one, then player 1 should win. Cool. Let's change that middle one back to a 2. And nobody has won. Yeah, that seems to work. Right, so we get in somewhere. Let's take stock of where we were. We were trying to build, originally, calculate the game state. Check for wins in rows. We can do that now. Check for wins in columns. We can do that now. Check for wins in diagonals. Let's do that. Last awkward method. I'm going to copy this again, because I reckon this code's going to be similar. Check for win. Check. There's only 2 diags. I'm not going to parameterize them. There's just 2 of them. Check to see if there is a win in either diagonal. There's no parameter. Check if player 1 is one in a diagonal. Right, so that's the type of thing I want to do. So check if player 1 wins. Oh my gosh, how am I going to do this now? Do you know what? This is a bit more complicated. Right. XOO. OXO. OOX. Player 1 is 1 here, right? We got to check 0, 0, 1, 1, 2, 2. 0, 0, 1, 1, 2, 2 is the same number. So player 1 wins is true. Let's use the same logic. Check I. Check if player 1 wins in top left to bottom right diag. Okay, and here I just check the same numbers, right? So 0, 0, 1, 1, 2, 2. I use this I, 0, 0, 1, 1, 2, 2, and it's parameterized by both sides, so it will just continue. That will work. That works nicely. If they've won, they've won. Good. Lovely. Can you see that working? So we loop from 0 up to, and not including 3, 0, 1, and 2. So we do 0, 0, 1, 1, 2, 2. The minute we find one of them where it's not player 1, we know player 1 has not won in a diagonal. So we set it to false. If they have won, we return. Good. Let's do the other one. O, O, Z? No, X. This one's harder. Right, so I'm going to copy this block of code, and we're going to try to put this one in the top right to bottom left diagonal. This is going to be harder. So what coordinates are we checking here? We want to check 2 across, none down. Then we want to check 1 across, 1 down. Then we want to check none across, 2 down. So one of these increases and one decreases. So we can have a for loop again for i's. And this second one is just the I, right? So that's correct. 0, 1, 2. But this one is not correct. We want it to be 2, 1, 0. How does that? I don't want another loop. I definitely don't want another loop. I can do this with one loop because I'm just looping. Pictorially, I'm looping over this, right? I'm just looping over that diagonal. So it indicates there should be one loop. I'm always trying to get these same squares. They're kind of inverted. So the row is going down, the second component is just counting, but the column is counting backwards. What if I do the board size, which is 3, minus the column, minus the count? So 3 minus 0 is 3, that's no good. What if I minus another one? 3 minus 0 minus 1 is 2. Okay, that gives me the first number here, with the second number being 0, you see? Oh my, sorry. Right. Right, and subtract 1. 3 minus 1 minus 1 is 1. Then subtract another one. 3 minus 2 minus 1 is 0. So 3 minus 0 minus 1 is 2. 3 minus 1 is 1. 3 minus 2 minus 1 is 0. So 0, 1, 2 could be our loop. Yeah? And I can compute these numbers. Yeah? So this number here is nothing but the board size minus the current I minus 1. So here, what I actually want is the board size minus the current I minus 1. So that's the particular, do you know what? I'm going to make that a little variable. Call to check is equal to that. Go away and think about that. If that's confused you, it should work out. We will find out if it does in a moment. Except I've just screwed up and changed the wrong thing, haven't I? Take those 2 lines of code, Liam, and put them down here where they belong, and change this back to what it should have been. That was an I. Right. So that checks the top left to bottom right diag. This checks the top right to bottom left diag for player 1. Then I'm going to copy all of this code. Again, this would have been really simple code if I hadn't parameterized the game. Okay, and I'm going to replace that block for player 2. And we're going to do check player 2 wins in the top right. Player 2 wins. Board is equal to 2, and the player 2 wins. And if the player 2 wins, we return the player 2 wins, and then we check and the player 2 wins in the other diagonal, and the player 2 wins, and if it's equal to 2, then the player 2 wins, and then we return that the player 2 wins. I promise you, this is the last hard method. I can't redeclare a variable. I'll just reuse it. Okay. Confidence I done that right. Not very high. Back to testing. Right, so we check diagonals for the win. It doesn't take any parameters this time though. Let's play it. Hope we got a winner. The both diagonals are not wins. Let's change this bottom corner to a 0. So that is note across, 2 down. Note across, 2 down. A 0 is player 2. 3 in a row, player 2 wins. Looks good. Change that back to a 1. Let's change these zeros here to a win, going up. So that's going to be that one in the middle. And just to not confuse anything, I'll put that one as empty. So, yeah, player 1 is 1 in this diagonal. Let's check the other diagonal, 2. Well, let's first of all see if someone doesn't win. Good. And let's put notes in the other one. So that would be a 2 here. And we get player 2 wins. And let's put 1s. And we should have player 1 wins. Ah, oh, cool. Seem to have done that right first time. The diagonals are checked. Yeah? Okay. So with that in mind, we check diagonals. We have enough utility methods to go back and finish doing calculating the game state. And this is really trivial now. Check for wins in rows. If any, stop as there is a win. Check for wins in cols. Okay, cool. So let's try to do this. Check for any wins in the rows. We need another loop. For int row equals 0, while row is less than the board size, row plus plus. I'm kind of regretting doing this board size now because it's really making this video more complicated than it should have been. But, oh well. Right, so we got the board rows here. If there's a win, we stop. So let's have a look here. Int state equals check the row for a win. Right, so we loop over all the rows and we pass the row number to this check for win. And what we want to say here is if that state that we've just got is equal to player 1 wins, or that state is equal to player 2 wins, then we can return whatever that state was. It's either player 1 wins or player 2 wins. I don't care which it is. It's one of them. Return it. We found a win in the row. Yeah, loop over all the rows, one by one by one by one. Check each row, get the state for that row. Our method returns ongoing player 1 wins or player 2 wins. If it's player 1 wins, or it's player 2 wins, one of them is 1 and we return, which matches our semantics here. Good, that checks the rows. Easy peasy. Then we can check the columns. So exactly the same code now, because we've pushed all the complexity into our utility methods. We've almost got a game. This is almost working now. I've almost got all the utility methods I need. Call note, check the column for a win. Good. Good. Then we want to check diagonals. Check columns. Here I can do check rows. So let's do check diagonals. I guess that's very similar. Yeah, it's going to be the same, isn't it? Except no loop, because we don't need parameters here. Check for diags. Oh, what did I call it? Check diags for win. There we are. Exactly the same. Right, so we've done that one. And the last part, we found no wins, so it's a draw or it's ongoing. Well, that's easy, isn't it? If is the board full, then we want to return game state as a draw. We didn't find any wins. The board is full. It must be a draw. Otherwise, we want to return ongoing. Okay, so now we've put our utility methods together to form a reasonable method here, which works out the entire game state. It does all the logic for winning, rows, columns, diagonals, but it does those via more methods, which we've written, right? So how many lines of code? 260 lines of code so far. Right, so let's take our method and go check it, calculate in the game state. So let's go back up to the top, change our little print method, calculate in the game state. And we got player 1 wins. Player 1 wins in so many ways here, it's a little bit of a joke. So let's make this be a bit better. It's not much better, is it? I've got to change some of these numbers. Right, good. Nobody has won. That looks good. If I put a note in the middle, player 2 will have won. Yeah, seems to work. If I put a 1 in the middle, player 1 will have won. Seems to work lovely. Okay, I'm not going to check all the possibilities of that. I'm pretty sure it's working because I checked all the individual methods that this method is built upon. So I think we're ready to revisit our main algorithm. Okay, let's keep going. Well done for following along if you're still keeping up. If you're not keeping up, reset at this point, as in hopefully you understand the board structure, and we've got these lovely utility methods. The ones we actually care about at this point are the ability to print a board, the ability to check if the board is full, and the ability to get the game state. If you understand the Java doc of those three, calculating the game state here, checking if the board is full, and printing the board, then you've got enough to finish the game with us. So let's look at our algorithm. Print a welcome message, easy. While somebody has not won and is board full, we've done all the methods for that, easy. Print the board, easy. Ask the player for row and column, easy. Place a piece at the row and column, easy. Yeah, this is finished. All we have to do is turn this code into Java. Okay. I'm not going to do it from the top. I think I'll do it from the middle. Right, so I'm going to take this out. I don't want to see this anymore. We do need to build a board at the beginning, okay? And I'll just code this up at the bottom. So let's do this printing board stuff first. So let's print the board, and now we want to ask the player for the row and column. So I might make another method for this actually. It's going to be a simple-ish method. Let's make a scanner at the top too. So we can have some input. Oh. I'm going to call my scanner keyboard. And I guess we should make it. Connect it to system.in. Oh, what's wrong with you now, scanner? Oh, it's not called scanner, it's called keyboard. Okay, there we are. Right. And in order to ask for these things, I'm going to make a little method. That's going to be the same. Asking the player for a row and column is going to be the same thing. Let's make a quick method, but I'm not going to implement it fully. Public static int ask player for position. Okay, so the idea here, let's write out the Java doc. Ask the player for their choice of row or column, right? So the idea is here, we can ask the player for where they want to go. I guess I'm going to pass a string here as a target. Bear with me. This is just making it pretty. So the target is going to be the string column or row, depending on if the player is inputting a row or column. Okay, so I want to use the same method for both rows and columns. It's going to return a valid index. That's important, a valid index. So the player's not going to be able to escape this method without typing something that's valid. Okay? Like that. So 0 to board size -1. Right, as the player, this method will keep asking the player until they enter a valid choice. Okay, so you're not going to be able to escape this until you enter a valid choice. Right, but for now, I'm going to keep this simple, okay? System.out.println please choose a target. Please choose a column. Please choose a row. Oh, how about enter column? Yeah, let's do that. Enter column, enter row. Fine. Then we'll do int input equals keyboard. That's my scanner dot next int. I'm just going to assume you actually type something correct here and return it. Okay, so we'll see this in use in a moment. So it prints a little message, gets the value and inputs it, and later on I can rework this so you can't escape this method unless you type something that's reasonable. But now we got this ask player for position. Is position the right word? I think it'll do. So let's come back up to our main method. Right, so we've printed the board, and now we can ask the player for a position. Should this input the column, then the row, I think. So int col is going to be asking the player for their position with a column. And then we're going to ask them for a row. Okay, let's see how that looks to start with. Enter column. Looks kind of okay. I'd like a gap here, I think. Try again. Okay, now we've got a little bit of gap. I might rearrange my windows here to make this a bit more sensible. Hang on, give me a second. I'm going to move that in there, pull this out, move my console up. When did I do this earlier? And get rid of this bottom bar entirely. Right, so my console's on the side now. Should have done that earlier. Okay. So it's over there. Enter column. Right. Okay, so print board, ask player for the row and column, place piece at the row and column. Right, so let's place the piece then. That's easy, I got a row and column. So now I just do board at that column and row. Go across this many columns, down this many rows, and set it to be, what are we setting it to be? Let's just set it to be player 1 for a moment and see how this works. So that's not going to do anything. So maybe here I will just wrap this in a while loop for a moment. While true. And play. Enter column. Let's go 1, 1. And it's put it in the middle. I've used indexes here, right? I'm just returning the row input, which is the index, 2, 1, right? So I'd like that to stop. I want, when the player types in 2, 2, it should be in the middle, and 1, 1 should be in this top left. Ask player for position, a valid index, 0 to board size. The choice of row as a human number, 1 to board size. Yeah, but we're going to return a valid index. So basically we're just going to subtract 1. So if I run this again now, enter the column, 1, enter the row, 1. Yeah, that's what I want it. I'm also going to get rid of this print line. So if I do it again, then it's just, I'm at the end of the row there, right? Enter column. Why am I looping? Did I put a loop in? Have I forgotten I put a loop in? I've forgotten I put a loop in. While true, print the board, new line, get the column and row, and set it to be an X. So let's just see if that works. 1, 1, 3, 1, okay, and 3, 3, and 2, 2, yay, cool. It's not checking I've won yet, I haven't done that bit of code, but we can start to place stuff in the grid. Okay, so we're doing that. This number 1 is not right. I need to play a number. So let's have a player number. Int current player is 1. And we can set that to be the current player. And then we can change player. So let's just do this in an obvious way at the moment. If current player is equal to 1, then current player is equal to 2, else current player is equal to 1. Yeah, so if the current player is 1, then they become 2, otherwise they become 1. Okay, let's try that. 1, 1, yeah, 3, 1, 0, 2, 2, x, 3, 3 is a 0. Good, that's working. Stop the game. Good. So, print a welcome message. Let's do that. Print welcome to Ultimate Naughts and Crosses. Okay, let's make this look pretty. We like prettiness. Could do this in a lot of different ways. Let's do another 2, 3, 4. Here we can do that. Obviously the method's not called print. Okay, let's see how that looks. What have I done wrong now? What have I done wrong? Oh, I've got 2 brackets here. Welcome to Ultimate Naughts and Crosses. Looks good. I think I'll have a new line printed underneath that. Naughts and Crosses, the board, enter column. Okay, but I need to know whose turn it is, right? I think we should have to tell whose turn it is. So system.out.print line it's player plus current player plus the turn. Okay, so now we should have whose turn it is being printed. It's player 1's turn. Can I give it to that? Yeah, okay. Cool. I'll just slide that across so the title goes off, but I think it's more important to see the code. It's player 1's turn. 1, 1, 2, 2, 3, 3. Good. I think, actually, I'll put brackets here. I'd like to see the symbol as well, okay? So I want to put the symbol in here. So something like an X, right? So it says, is player 1 X turn? Yeah? So how do I get the symbol? Well, we had a method for that, right? Cell value to symbol, where we pass in the current player. Yeah? So it's player 1 or 2's, and then the symbol for that player, X or naught, turn. Yeah, let's try that. It's player 1 X turn, 1 1, naught's turn, 2 2, 3 3. Good, working. But let's look at our algorithm then. Print the welcome message we've done. Print the board, ask the player, place the piece we've done. We've got this part at the bottom and this while loop to do. Okay, let's tackle this while loop then. So while somebody has not won, and the board is not full. That's just our game state, right? Our game state method, calculating the game state, where's it gone? Calculate the game state. The game state's ongoing, if it's ongoing. draw if it's a draw, player 1 if they win, player 2 if they win. So we just need to loop while the game state is ongoing. Oh, that's easy. While we calculate the game state, and that comes back as ongoing. So while the game state is ongoing, we keep looping. Wow, that's easy because of our utility methods. So let's try it. Let's just win in a diagonal. 1, 1. Oh, what am I doing? Stop. Start again. 1, 1. Let's put the second player in 2, 1. Let's put the player 1 in 2, 2. Let's put player 2 be playing silly. 3 across, 1 down. And let's put the player 1 in the other corner, 3, 3. And the game stopped. Good. So the last thing we need to do is this part, which is basically that code, right? So let's have a look. Well, let's get the game state. So, sorry. If we get outside this loop, int state equals calculate the game state again. It doesn't matter how many times we call that method, it doesn't change the game state, it only checks it. If the state is equal to player 1 wins, then we can do system.out.println player 1 wins. Okay, and we could do an else if the state is equal to that, then player 2 wins. Else it's a draw, right? It's the only other outcome. It's a draw, right? Okay. Print end message. Okay, so main method is really simple. I've just implemented that algorithm. It almost fits on a screen of quite a large font. I've increased my font here for the video. So printer, welcome message, loop through printer board. It's readable. You don't need many comments here, right? Okay, let's see if it works. Let's play this once or twice to see if it works. Player 1, right, 1, 1. Player 2 can be in 2, 1. Player 1 can be in 2, 2. Player 2 can be in 1, 3. Player 3 can be in 3, 3. It should win. Player 1 wins. Cool. Oh, what's happening here? I didn't see the winning board. Enter column row. And I'd like to have seen that board. So why didn't I see that? I didn't see that because this represents the start of a turn, right? So once we've won, we'd like to see the board one last time. Row column. That's a new turn here, right? So actually, I think we should put a print here too. Get rid of that one. And we just do that. Here, print final board. Let's try it again. 1, 1, 3, 1, 2, 2, 3, 1. What did I just do? I've just put a piece over a piece. I shouldn't be allowed to do that. Come back to that in a second. Player 1's turn, 3, 3. Player 1 wins. Okay, we're almost done. But we were able, here look, that was the state of the grid, and I put a piece in column 3, row 1. Column 3, row 1 here, I put a piece there again. I'm not allowed to do that. That means I can also change people's pieces. So if player 1 goes in 1, 1, and player 2 goes in 1, 1, we can just change the piece. That's not allowed. Okay, so here's the problem. We print the current player's turn, we ask them for the row and column. Or we just place it, we don't do any checking. So here we need to do some checking of if they're in the right place, right? So we need to do something like, before we do this, if the board at the column and the row that the player picked is not equal to 0, then we need to do something. We need an error. But we want to keep asking them, right? So this all has to go in a while loop. So while something, we want to ask the player, do the check, and only if we get out of the while loop do we want to actually make the change. Place the piece. Now, the row and column are declared inside the while loop at the moment, which means they're destroyed once we get to the end of the while loop. I don't want that. I want them to be available afterward. So int row, int col. Let's have a boolean valid choice is false. Okay. Player made valid choice. We can keep looping while the player has not made a valid choice, and if it is equal to 0, then we can say they did make a valid choice. Otherwise, we can print a little message error system.out.println that cell is already taken. Pick again. Okay, and what's wrong here? The local variable call may not have been initialized. That's just Java, that's Eclipse not being able to work something out here. So my player made valid choice is false. We have to go into the loop, but it doesn't know that. I'm just going to set these to 0 to start with. Should fix the problem perfectly fine. Let's just try that. Let's go in 1-1. Let's go in 1-1 again. That cell's already taken. Pick again. Pick again is slightly off the screen. Let's just have a look. Yeah, I haven't done full stops everywhere. Let's give it a full stop. 1-1. It's already taken. Pick again. 1-1. Can't go past it. 2-2. Does it work for player 2? Player 1 can now pick 2-2. Yeah, that's working fine. Okay, let's stop that. Good. We're almost there. Almost there. Okay, the last part to finish then is sorting out the keyboard input. Let's sort this out. There are coordinates, right? Okay, so the last part to sort out is what if we type in invalid cells? Let's say 11,11, then we get a crash. I suspect it's an array out of bounds crash. Index 10 is out of length of 3, and it's coming from here where we try to put it into the board. Now, I want all of this to be captured in this method, so let's go down and have a look. This method is right at the bottom. Right, so I don't want this method to return unless you're typing in something that's valid, and something that's valid is between 1 and board size. So let's see if we can do that, okay? So I want a while loop, again, of something. So you're going to keep going around here until you type in something that's correct. Right, so how about we have boolean is valid. It can be false to start off with. And we keep going while your not is valid. So while not valid, how about we have choice is valid. Yeah. Or position. Position is valid. Position. Yeah. So while the position is not valid, we will keep asking. Right, I need this input available like before outside the loop, so I'll set it to be 0. Actually, I'm going to call it position, I think. We're going to return position -1 and we set it here. Well, we read the keyboard, right? And then we can say, if position is less than 1 or position is greater than the board size, then we get a problem, right? Although let's do it valid, actually. Let's do it valid. If it's greater or equal to 1 and it's less than or equal to the board size, then we're valid. So in that case, we don't need to do anything. Yes, we do. We need to say position is valid is true to get out of the loop. Otherwise, we can print a message. Print line. Invalid input. Input must be between 1 and the board size, right? That should do it. Right, so position is not, position start valid is false. While we are not true, we print out please enter something, enter the input. If it's check it, if it's in range, we exit the loop via this. Otherwise, we print a message and then we return the position at the bottom. Good, let's try that. 11. Well, that didn't work at all, did it? What have I done wrong there? Oh, I don't want a 1, I want an AND. Try again. Right, 11. Invalid input must be between 1 and 3. 11. I can't get out of entering the column, so let's enter column 3, row 11. Let's enter row 0. Still 1. Good. Perfect. The only other little thing is, what if I type a string? Then I get another crash because on this line we're expecting an integer. So let's see if we can fix that too. So let's say here, let's change that a little bit. String. No. How can we do this? Let's say if keyboard dot has next, oh my god, has next int. So while there is an integer to read, and this method will block. So imagine you haven't typed anything. What does this method return? Well, this method doesn't return until you do type something and press enter. So if the thing you just typed is an integer, what do we do? If the thing you just typed is an integer, then we will do this bit of code. Else, we'll print another message. I think I'll just print the same message, okay? So I'll just put that as a string at the top. String error message is equal to that. So down here, we will just print the error. My typing is going. Error message. And we'll do that in the else as well. So let's just recap here. If there's something that's an integer on the keyboard, we will read it and check the range of it, and either finish the loop or we do an error message and go back to the top of the loop. If it wasn't an integer, we will print out an error message, but critically, we've got to read that bad data and get rid of it. So let's just do keyboard dot next line. Read everything that's there and throw it away. Now this returns something, right? But we don't have to use it. We can just throw it away. Throw away bad input. We don't have to do that here because we did really read the integer off the keyboard. And so that's fine here. We didn't read anything off the keyboard. We just tested it. And so we do need to throw it away. Okay, let's try that. Column 11, invalid input. Column blah, 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 invalid input. Enter. Okay, if I just press enter, I'm entering nothing. But I can put 8, invalid input, minuses, pluses. Good, I can't crash this now, it seems. Funny symbols. Good. So let's go 2, 2. Yeah, seems to work. Right, we have a finished game. Good. let's have a bit of a recap of this. Not bad. How many lines? 330 lines for a fully implemented game of Naughts and Crosses, where you can actually change the board size between 0 and 9. 1 and 9. So this will work. I just realised though, it's not 3 in a row anymore. It's a full row, a full column, or a full diagonal. It's going to be very hard to win this game, I think. But nevertheless, we have finished it. Interestingly, does it work on size 1? Can I play a game of 1 square? 2, 2? 0, 0? Yeah, 1, 1? Yay, player 1 wins. First person winnable game. Player 1 always wins if they make a valid move. Okay. Right, let's reset the perspective here. So I'm going to go up here and just reset this. So it goes back to what it should look like. Or normally looks like, I should say. Right, so this game is finished. Not too bad in my opinion. I know it's a lot. Well, is it a lot of code? 330 lines for a game of Naughts and Crosses? This board size made things a lot more complicated. If I didn't do that at the beginning, maybe that was a bad move for this tutorial style video. It's made things a fair bit complicated. The main method is still the same, but what's got more complicated is printing the boards got a little more complicated. Checking the board full is a little more complicated. The game state method is perfectly fine, but its methods, the check row for win, check column for win, and check diagonal for win, are all pretty complicated compared to where they would have been. They're much more complicated. But okay, we got through it. Let me just run through this code so you've got it all on one screen. So you've got lines 1 to 28 here. Then we've got lines 28 to 54 here. Then we've got 54 to 80 here. Then we've got 80 to 107 here. Then we've got 107 to 134 here. Then we've got 134 down to 160 here. Then we've got 160 down to 187. 187 down to 213. Then 213 down to 240. Then 240 down to 266. And 266 down to 290. And fine, oh, do we keep going? Yeah, 290 down to 313. And then 313 down to 330. So that's this completed. I'm quite happy with the result really, other than slightly making things more complicated with the variable size boards. One thing I could have done differently, I've done this from a bottom-up perspective. I wrote a high-level algorithm at the beginning, and then we really went to the very bottom and built utility methods and put those utilities together. So we started off by doing, what did we do first? We printed the board. That's a utility method I would always start with, actually. I always want to be able to see my data before I start programming. But beyond that, we then chose, I suppose, to start doing the isGameBoardFull method, which was quite easy. And then we done the calculateGameState and built the sub-methods. The alternative approach would have been a top-down approach. I would have started with a high-level algorithm. I would have still probably done my print board method then, because I really want to see my data. But then I would have tried to implement this main algorithm with holes. And for instance, I would have had here while true. So I wouldn't have had the calculate game state method implemented yet. I want to get this high-level algorithm done. So I would have just done something while true and left holes where I fill in the methods later on. And so that would have been a top-down approach. But it's personal preference. I use a bit of a mix usually. I've done a little bit of top-down here, but mostly bottom-up. The top-down I done was implementing this calculate game state method where I thought about the method and then I realized I needed more sub-methods. So that's implemented Naughts and Crosses in approximately 2 hours. Feedback welcome. I can always do more videos if you want. Let me know. Thanks, guys. Probably the most important thing here is not getting this game working. It's how you go about tackling things. I've tackled this by thinking slowly and systematically through the problem. And then every time I've built a method, I have gone and tested it in the main method. I only built the main method at the end. If you're doing top-down programming, I would be constantly commenting this out and writing a couple of lines at the top to test my new method. Once I'm happy with that new method, I delete those lines of code and I restore my main method and continue. That would be the top-down approach I would take. If you want to go a step further, you would use unit tests and kind of do a test-driven design approach. But lots of ways to do it. Many right ways, many wrong ways, I guess. But whichever style works for you. The main thing is you've got to keep running your code and making sure what you're writing is working. I don't usually like to write more than one method without really assuring it is working correctly. And certainly without putting that into other methods. Okay, I'm going to wrap it up here. Thanks for listening and surviving till the end of this video, if indeed you're still here. Well done. Thanks, guys. See you around.